Okay, do I give you enough information here? The energy profile following exothermic SN2 process. So exothermic means what?
SN2 or SN1?
So thermic, it's going down.
So it's going down. That's all I needed. I needed the wells. I don't care what it is. I know that it is exothermic, so the final has lower energy than the starting part, right? Okay. And now, it's going to be an SN2, which is a one-step process, so I can go ahead and draw that. And then I've got, on the reaction side, I've got methyl iodide, CH3I plus hydroxide. And then on the product side, I've got methanol plus iodide. And now the big problem here is include the reactants products, and I'm going to try and draw this. What I need to know, is this transition state early or late?
Early. How do you know it's a one-step process?
Because it's SN2. SN2, do you get the handout on organic, some organic mechanisms? It's in that.
Okay.
This is an SN2 process, so it's one step. It involves backside attack, which should remind you all. This is a backside attack problem of the hydroxide, and it's going to attack on the opposite side from the leaving group, which is iodide. And is it early or late in its transition state?
Early.
Early. So that means that the transition state's going to look like reactants. So I've got the methyl iodide with the iodide.
Did you say on the paper that it's an SN1 process, but you just told us it was SN2?
It says SN2.
This is SN2.
On the key it says SN1.
Oh, that's because I'm an idiot. Okay. Sorry. Now, I'm going to draw this so that it's going to have the iodide leaving group.
Are we supposed to know how to draw?
It's going to be tetrahedral. It's puckered tetrahedrally so that this is the top of the tetrahedron, and the OH is attacking, the hydroxide ion is attacking on the opposite side, the back side of the leaving group.
Are we going to have to be able to draw that?
Yeah.
Well, the main feature here is, since it's an early transition state, it would look like, it's going to look more like, here's the iodide on top with a hydrogen here, a tetrahedral. Let's just look at the substrate molecule. You should be able to draw that one from Chem 1A. Okay? And what's happening is the hydroxide is attacking on the back side, on the opposite side from the iodide. And it still looks more like the methyl iodide. If it was a late transition state, this is because it's early. This is an early transition state. If it was a late transition state, let's say it was going this way, then what it would look like would be the hydroxide would be on top with it puckered down for the hydrogens here. And then the iodide would be here. Okay, so this would be the tetrahedral structure, and the iodide, so you see the iodide would have these bent around that way, the iodide would be further away, and the hydroxide, it would look more like the product methylol. That's the product. This is the reactant. And so if it was symmetric, And the symmetric one's the most interesting one. It's going to look like this. The carbon goes up. It is actually a trigonal bipyramidal structure with the iodide there. This is symmetric.
So everything's in transition.
So this is where what it looks like. The transition state here looks this is an early, and now I got so this denotes the transition state. What else did I have to include in here?
Delta G naught.
Delta G naught. And after the first problem, that part should be easy. And delta G double dagger. Okay. And what else did I have to include? Include reactants, products, activated complex, label the free energy of the reaction and the free energy of activation. Is the entropy of activation positive or negative? Is it going to, so I've got two reactants going to one. So I would say the delta S is, there's fewer. There's more degrees of freedom here.
Also go backwards, yeah.
Yeah, there's more. So I'd say it's got a negative entropy of activation. It's more ordered in the transition state than it is here, where I've got two molecules free. And then, what is the next problem? Is electro restriction increased to relax in the activated complex? I didn't talk about that in the lecture. Well, I can tell you what it is. It is, trust, I'll take that off. That's not going to be on the test. So don't worry about electrorestriction because I don't have time to even delve into. All it is a simple concept. Electrorestriction is when a charge approaches something, the effect of the field is to cause a distortion in the other molecule.
That's called an
That's called electrorestriction. And what actually happens if, like, if I have two charges on the opposite sides of something, the field that's created is going to cause a distortion where it's going to bow out. And there's going to be a distortion. So the extent that that distortion occurs is called electrorestriction. Don't worry about it. I'm going to remove that since we didn't talk about it in lecture. Yes?
F is the hard one.
E is the transition state, early, symmetric, or late. What is it? Early transition state. It's closer to the reactant. Yes, Robert?
S is kilojoules per mole per Kelvin, right?
S is usually joules per mole per Kelvin.
Yeah.
But it can be kilojoules if you like.
Yeah. So, but my question is, since it goes down in energy, I'm guessing it goes down in temperature?
Well, the S is not, don't think of it in terms of temperature. Think of it in terms of the number of microstates that exist. There's two molecules here. There's one uber molecule there. So that would be, there's less vibrational modes available, and that means I'm going to have fewer microstates, so delta S is going to be a negative.
Okay.
If you're going to an increase in entropy, there's going to be more microstates.
Yeah.
Okay, and we're going back to the Boltzmann approach, actually, the connection between probability and entropy. And so there's fewer arrangements of this, there's more we're having a decrease in entropy going to this transition state. Yes?
So ours, letters C and D, are they going to be taken off? For the
We'll
final?
take out the, C, but I left out what effect would increasing the polarity of the solvent have on the rate of the reaction. That's still in there. What would happen now, let's look at this. I've got this charged material, I've got now a partial minus here, a partial positive there, and a partial minus here. But actually, look at that charge. It's all spread out. So I'm not really seeing a buildup of charge in the transition state. I'm seeing actually more focused charge here, neutral here. I would say it's slightly decreased. So increasing the polarity would really slightly slow it down. That's it's negligible, and you can look at the handout on organic. Yes.
So is the total charge on that, on the activation, at the top of the activation complex, it's got two negatives and a partial positive.
Partial positive, partial. Okay, so I'd say maybe.
The net is slightly negative.
Yeah, because I have here a negative and a neutral.
Right, and because that's slightly negative on top, that is going to slow it, because if you've got negative charge.
Yeah, but yeah, there's it's
That's why it loads a little bit.
yeah, it's a slight it's actually this spread out in the transition state. It's it's not really.
It doesn't have to do with total net charge.
Yeah, it doesn't really have an increase in net charge.
Okay.
What's B?
What is B? There's those little things that fly around and make honey. Sorry.
I'm a B. I'm a B.
I'm really sorry. That was really bad.
No, it's perfect. What is the answer to B?
To B, is the entropy of activation delta S double dagger positive or negative? It's negative. Okay? And C, what effect would increasing the charge have? That you can read through the handout to get that information on the organic SN1 and SN2 to reinforce that. Number D is taken out. E is the transition state, early, late, symmetric, or late. It's early. That one I expect to leave in. F may or may not be in there, and F is how long is a piece of string? Everybody knows the answer. What? Absolutely.
So if I just answered that one, then the rest of the test.
Well, I don't know if that's going to be on there.
Are
Okay.
you going to be rearranging this with other stuff?
What I'm going to do is we've already said there's going to be a one question on number 8 is going to be